So what is an elastic collision? An elastic collision is a collision in which the kinetic energy is conserved. Now you might think, what do you mean? Isn't kinetic energy supposed to be conserved all the time? Isn't that the whole point of energy conservation? Energy conservation, not kinetic energy. Kinetic
Hmm.
energy can be lost, converted to other forms, but that doesn't mean that the total energy in the system is decreased, right?
Right.
So elastic collisions are the special kind of collisions, which are very rare, by the way, in the real world. You almost have none of these, where kinetic energy is conserved. So the initial amount of kinetic energy is exactly the same as the final amount. The reason that it's not conserved and it's extremely rare for it to be conserved in a system in the real world is, for example, even if you take like perfectly round metal balls and you like hit them, they're
Hmm.
gonna lose a tiny bit of energy to sound and vibrations and heat, right?
Okay.
So that's why some of the kinetic energy is lost. You see what I mean?
Yes.
So, but anyways, elastic ones are the very rare cases, almost never, where kinetic energy is conserved. Inelastic would be where they're not conserved. Okay?
Right.
And
Okay.
that is why they come a lot in parts of momentum problems.
Okay.
Anyways, so how do I memorize this? I like to think about it like elastic means that, an elastic will come back to its original state once you stretch it, correct?
Yes.
So, like I try to like think about the analogy that the elastic part is kinetic energy bouncing back to what it used to be. That's why elastic ones are where kinetic energy is conserved. I can't
Right.
think of any better like way to remember this. I used to mess this up all the time. Anyways,
Okay.
so this is realistic. The total loss of kinetic energy is 63 joules. So remember, there's two collisions happening in the system. First, A and B collide, become one big, ball, and then
Hmm.
AB, D basically, collides with C to become another big ball. So there's actually just two collisions happening. Okay? So use the result. By the way, a little suggestion, just a small tip. Instead of drawing D like this, I would have drawn it like this and then
Mm.
written D above it to remind myself that that is what D is. Kind of
Okay.
helps. Just a little, can help you
Right.
track. Anyways, uh, okay, so you have lost a bunch of kinetic energy. Use the result from A to show that V equals 3. Okay, this is easy. Look, if you look at this whole thing, you might, you see two collisions happening. But when we're talking about a set of collisions and we're talking about conservation, we're talking about initial and final. We don't care about what's happening in the middle, who's shaking hands with who. All we care about is what was happening right there and what's happening right there for conservation. What's
Right.
the kinetic energy before anything ever happened? The kinetic energy initially, what do you think?
Um,
So
it's
let me. hmm
kinetic energy is mgh or
Half, no, no, half mv square. Kinetic requires velocity, right? So,
right.
uh-huh.
So the initial kinetic energy is half times 5
hmm
times g.
6. That's 6.
Oh, right, v. Okay.
No,
So,
6. A is at 6 meters per second.
yeah,
Uh-huh.
v
Plus.
squared is 6. Okay.
Mm-hmm. Oh,
Plus,
yeah, 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 exactly. V is 6. Yeah, sorry.
yeah.
Go on.
Plus half times 1.
Well, we don't need to write that because the poor guy's static.
Yeah.
Zero velocity means we don't need to consider him.
So we just are considering the particles that are moving.
Yeah, because kinetic energy requires velocity. If velocity is 0, the whole thing is 0.
Right. So
So,
2
yeah,
v squared.
exactly. And we don't know V yet. We're trying to prove that it's 3. So, and
Yeah.
what's the KE finally after everything is said and done and the little e is just moving in space alone?
Just half times 8, the weight of E. And then we don't know the velocity
But
or
we do
the,
know
right.
that
So,
VE is 15 minus V
right.
over 4. And this is nice because
Right.
we also know how much is the difference between these two values.
Mm.
You see what I mean? Because we know that they're not equal, first of all, of course, because it's inelastic. They've kind of told us that by telling us that there's a loss of 63 joules. So they've
Right.
told us that if you look at the initial velocity, sorry, initial kinetic
Right.
energy,
Minus the initial one is
exactly.
63. Right.
Initial minus final technically will be 63 because the final is
Mm.
going to be less, right?
Okay.
Yeah, so this is going to be 63. Uh, did I do something wrong? Yeah, this is plus. So again, initial minus file because we expect this guy to be lesser than this, right? Because we've
Yes.
lost energy. We can't gain energy somehow. Gain kinetic energy at least. So let's try to do this as cleanly as possible. I'm going to multiply everything by 2.
Mm-hmm.
Is that the best idea though? Maybe it's not. Yeah, it's not. When I cancel this out, I'm going to make this 36 and then I'm going to cancel out with an 18
Mm-hmm.
and I'm going to cancel this with a 4. Oh, this is nice actually. This is working out pretty nicely. So you have
Mm-hmm.
5 times 18 on the first term, which is 90. You have v square. And now here, I'm gonna foresee that this is gonna become a 16, right? And 4 cancels out with 16 to give you another 4, which leaves you with 15 minus v whole square equals 63. What do you think?
Yes.
Perfect. So now
Yes.
we just need to solve this very big quadratic equation that's about to pop up. Maybe
Okay.
I'm gonna multiply everything by 4. You'll see
Okay.
why. I don't wanna have a
Yeah.
fraction in my. So you have 15 squared, whatever that is,
Mm-hmm.
225. Now be careful with the signs. Don't do this the way I'm doing it. Open it up slowly, but
Okay.
can I have plus 30v and then minus v square equals 63. And now I have 3v square plus 30v, and then you have 360 minus 225 minus 63, which is 72.
Right.
And I'm gonna solve this quadratic in my calculator and hope that I haven't messed up the mental math.
Mm-hmm.
Nice. Velocity comes out to be -4 or -6. Hmm, interesting. How could I get two answers? I mean, I was expecting two answers, but why? Ah, okay, neither of them are right. That's nice. So that means I've made a mistake somewhere.
Okay.
Okay, so, hmm, just a second. X squared 36, 2 cancels out, gives you 18. 5 times 18 is 90. 90, okay. 2's cancel out, v square minus 4. 4 cancels out, gives you a 4 here. Um,
Is
is
that
9
supposed
times?
to be,
Sorry,
sorry, is
go
that
on.
supposed to be negative 30V or is it
I
positive?
was expecting a -30 from here, but then there's another minus outside, so I made it positive.
Ah, right. Okay.
Yeah. So minus is 15 squared 2 to it is right. Yeah. 2 to 5 plus 30v minus v squared because I would expect a plus v squared, but there's a negative. And then
Mm-hmm.
63. So now I have 360 minus 2 to 5 minus 63, which is 72. This is 30v, and 4v squared minus v squared is 3v squared. So what's the problem then? Yeah, -4 -6. That's not good. Did I get this wrong? 1 over 2 m v squared plus 1 over 2 2 v squared. Exactly. And I have 1 over 2 8 15 minus v over 4 whole squared. Wow. The total loss is 63 joules. Use the result to show that v is 3. Okay. 6 squared is 36. 2 36 cancels out to give you 18. Yeah, for sure. So 5 times 18 is 90. V square. Uh, okay. 4 squared is 16. Cancels out with the 4. Gives you a yeah. Gives
Um,
you a 1 over 4.
the mark scheme says that that quadratic, the 72 should actually 117. 100 negative 177. Why can't I say that?
Minus
Negative
1 7.
yeah,
117 or 1 7?
117.
Oh wow.
Yes.
Okay. Wow. That is interesting.
Yeah.
Whoa. Oh my God. Oh God, I do this so often. If I multiplied everything by 4, why did the 63 not get the 4?
Right.
I do this so often. It's crazy.
Okay.
63 times 4. 252. And now you have 360 minus 2, 360 minus 2 to 5 minus 252, which is negative 117. God.
Mm-hmm.
Okay. So we have 330 minus 117. And that is exactly, you have two choices, 3 or minus 13.
Yes.
I am not sure why we disregard the minus 13 though. I
Mm-hmm.
wonder why. Because maybe if we, yeah, it makes sense. I mean, how could the velocity, okay, if d is heavier and it's moving in the right direction,
Mm-hmm.
how could c be moving faster in that direction? It's
Right.
impossible. So v has to be 3 therefore. Anyways, so that's that.
Mm-hmm.
Okay, now we're in equations of motion. It is given that the distance xy is 36 meters and yz is 98. Okay, so what do we know? We know that A, B, and C in the very beginning were at x, y, and z. This
Mm-hmm.
distance is 36, distance is 98. A is moving with 6, C is moving with 3. No,
Okay.
C is not moving with 3, sorry. Or is it actually? C is moving with 3. C is moving with 3.
Mm-hmm.
That's what we just found. So C is moving in that direction with 3, which means that, um, yeah, that's all we know essentially. Now, we need to find out the time it takes for A to collide with B first, right?
Mm-hmm.
And then we need to find out the time it takes for C to collide with AB, basically. Okay, so let's first find out the time it takes for A to collide with B.
Mm-hmm.
Uh, do we need to do that actually? I just realized. We might not need to do that because they're saying time between the two collisions, right? So let's say we start the timer when A and B collide and become one thing,
Mm-hmm.
okay? Like they become D, and D has a speed of something. What did it? Yeah, 5, right? We found out that it was 5. And it's, I mean, obviously in the very beginning, right when they collide, when A and B collide, they're going to be at Y, aren't they?
Mm-hmm.
Yeah. And C is going to be at Z. Why is this? Is this clear to you so far?
Yeah, it is.
The reason I don't want to know the time between it takes for A and B to collide is because I don't care. They said time between the two collisions. So I start my timer when when D is born, and
Mm-hmm.
then I measure how far these two guys are. I know that this guy's oh, he's not gonna be here anymore. When D forms, C is not gonna be here. C is gonna be somewhere here at that point,
Okay, yeah.
right? Because was moving. So that is why I need to know how long it took for A and B to collide. Because I need to know then where C is when they do collide. You see what I mean?
Yes, I do.
So I was trying to cheat the system, but yeah. So B is stationary, so that's nice. I literally it's just a question of how long A will take to move 36 meters. That's like super easy because you know the velocity of A is 6. The time for A to get to B. So you can use your own notation, honestly.
Mm-hmm.
It helps. So time for A to get to B is gonna be, what's the formula for time? This is it distance over speed, right? Yeah.
Yeah.
Yeah. So distance over speed, so that's going to be 36 over 6, which is 6 seconds. Okay. So how far did C move in those 6 seconds? We need to find that out now. It's going to move, so we can call it the distance that C will move in 6 seconds. God, I need to log this 1 second.
Okay.
It's going to be the speed it's moving at into the time. So 18 meters or whatever these are. Yeah, meters. So if now let's draw the situation at that point, right?
Mm-hmm.
So at this point, essentially, C is no longer at Z. He's long gone. He's somewhere here now.
Right.
And we know that if this position was 36 meters, let's say that X is like, it's a ruler, okay? Let's say this is 0 meters, which means
Okay.
that this position would be 36 meters, which means
Mm-hmm.
that this position would be 36 plus 98 meters.
Yes.
Or actually, it's easier than that. We can just say that this distance is 98 minus 18, basically.
Right.
Yeah. So this is 80 meters now. We don't
Mm.
care about anything else at this point. All we care about is how far is A is d from c. C is still moving at 3 meters per second. Do you agree that this is the case? 98 minus 18 basically, because that's how
Yes.
far c moved, right? Okay, good. Now we have to figure out how long it will take for these two guys to meet. Do you have a specific method you use to find out these kind of situations where two things are moving towards each other or away from each other and you want to find out how long they will take to meet?
No, I do not.
Okay, because this is a very common question. Like two trains are moving in the same direction, one is faster, one is slower, when will they meet? Or two
Okay.
trains are moving towards each other, when will they collide, etc., etc.
Hmm.
How do you do this? Give me a second. I used to have a really nice method for this. Let me remember it.
Okay.
So we're gonna use we're gonna use the idea of displacement. Okay.
Okay.
The cool thing about displacement is it's not distance, it's about position. Where are you, essentially? Not how far you've moved, but where are you right now? Okay. So when I say S is equal to ut plus half at square, for instance, I do
Hmm.
not mean that this is how far this guy will move. I mean this is where he will be if he is starting from 0 meters on the ruler. Where will he be after this much time? Okay.
Right.
So similarly, okay, let me think. Let's say that the initial position. So what I'm going to do is I'm going to say that this is standing at 0 meters and this guy is therefore standing at 80 meters. Do you agree with this
Yes.
analogy? Okay. Now, the position of D at any given time will be equal to uh, how fast it's going into the time that is moved. For example, if I want to know what position it will be at in 2 seconds, I will just do 5 times 2. It'll tell me 10 meters. It'll be at this position. You see what I mean?
Right.
Okay.
Okay.
This is the position that D will be at any given time. I've made a function of the position of D at any time. Similarly, I can make a new function for C, but be very careful. The position of C is initially 80 meters, and after every 1 second, it's moving like towards the left. It's moving towards 0. So its displacement position number is changing by decreasing. So its new displacement at any given time will be 80 minus 3t. For
Okay.
instance, after 1 second, it will be 80 minus 3. It will be at 77 meters. After 2 seconds, it'll be at 74 meters. You see what I mean?
Yes.
So this accounts for the fact that its initial position is 80 meters. You see what I
Right.
mean? Now, all I want to know is when will their positions be the same? That's the question. And this makes life super duper easy. I
Mm-hmm.
know that it's a bit of a complicated way to think about it, but when you understand displacement like this, when you can visualize displacement like this, like
Mm-hmm.
these questions are child's play. Look at how much working there is. Like 2 lines, that's it. I just need to solve this equation now. I'll
Right.
add 3t to both sides and I'll divide by 8. So it'll take 10 seconds for them to be at the same position, which is an analogy for them colliding essentially.
Okay.
So that's it. Now, recap, right? So check your initial situation. Where are the two boats? Pick one of the boats to be at 0 meters. Pick the other boat to be at whatever position that, however far it is, just pick that position. So 80 meters, for instance, in this case. Put down their speeds. Now, use the idea of displacement to say that if the initial displacement of D is 0 meters, then after some time, its new displacement will be 0 meters plus 5t. And similarly, so this is D. And similarly, if the position of C initially is 80 meters and it's moving leftwards, its new displacement after some time will be 80 minus 3t because you're taking away from that position value.
Right.
And we want these positions to be the same, so equate them and find the answer.
Okay.
You see? So a bit of a complicated way to do it, but I'm sure you find this very elegant because it uses the true nature of displacement. It's a position value. Okay?
Right. Okay.
So do you like this or on the mark scheme, do you prefer that solution? Like, does it look better to you?
Yeah. Yeah. I think it does.
No, because if you want me to explain the mark scheme one, we can talk about that.
I mean, it's when I'm looking at the past paper, it's basically the same, but
Oh,
now
perfect.
an explanation. Yeah.
Perfect. Okay, that's nice. Because
Mm-hmm.
sometimes they use this weird thing where they say that, okay, let's assume they meet at this distance,
Mm-hmm.
and then it's a long, weird method. It was 4 points, so I was worried. Anyways,
Okay.
find the time between the instant that A is projected from X and the instant that E reaches Z.
Mm-hmm.
So we already know how long it takes after D has formed and hits C, right?
Okay.
We already know that part. All we gotta know now is how long. Okay, we also know how long it took for A to become like A to hit B. So the first thing is A hit B becomes D. That's the first thing.
Okay.
Then D hits C becomes E. That's the second thing. And number three, E goes to position Z. We
Okay.
already know how long this takes. It takes 6 seconds, right?
Right.
For A and B to collide. We already
Yes.
know how much this will take. It will take 10 seconds for
Mm.
D to hit C and collide. 10 seconds. Now all we gotta know is like we know how fast E is moving. We know how far. Ooh, ooh. Okay. So we don't know how far E is from Z at this point, right?
Mm-hmm.
However, the previous question helps us find out what that position is where they do meet. We know that they meet at 10 seconds, right?
Right.
Where is E when it forms? Well, we know that the time that they meet is 10 seconds, which means that we can find the position of D and C because they'll be the same at 10 seconds, which will be 5 times 10, which is 50 meters, which means that your E forms somewhere here
Okay.
at 50 meters. Okay.
Mm-hmm.
Now, this is 50 meters, right? This length. So, and we know that this is supposed to be 98 meters, right?
Okay.
So, what's the distance between where E formed and where Z is? 48 meters. So, that means it's 48 meters from Z.
Okay.
Okay?
Mm-hmm.
So, which means that I can find out the time that E will take to get to Z, which will be the speed that E is at. No, sorry, the distance from Z
Uh-huh.
divided by the speed that E will be at, which is found as VE. Where is it? 15 minus V over 4. Since we know V is 3, we can say that VE is, by the way, VE is 15 minus V over 4, which means
Mm-hmm.
15 minus 3 over 4, which means 3? No, what is 12 over 4? That's 3, isn't it?
Yeah.
Yeah, so that's going to be 48 over 3, which is 16, and that is it. You bring such tough questions, I swear to God.
Yeah.
16 seconds. So now we know all of them, which means we
Okay.
can just add all of these up, and that'll be the total time for all of this mess to happen.
Okay.
Okay, this was a insane question. Oh, it's the sixth one. That's like one of the last ones in the paper then, huh?
Yes.
Yeah, the last three are normally like super tough, so it makes sense.
Mm-hmm.
I really wanted to go over the last pulley one, but I'm like exhausted now.
Yeah, no worries.
Yeah.
We can do that next lesson.
So yeah, let's look at the pulley one next time. It's a bit of a discussion. I want to talk about some interesting ideas about pulleys next time too.
Okay.
I think we already talked about the tension thing last time with the car and the trailer, but
Okay.
still there's ideas about the pulley system that are special to it. So we'll talk about that next time.